Welcome to Algebra 2, review day number 5. This will complete our review of the problems in your EOC packets, and following this, it will just be Q&A to go back over some of the problems that maybe we glossed over a little bit or you'd like to see again if you were absent or you were watching one of the videos that did not go as well as maybe I would have liked it to go. So without further ado, let's dive into this and hope that everything is working the way that we want it to be working. So we have question 28 is where our last video left off, and you'll notice that I've got this slide and the next one do not have Desmos on them. So while Desmos is super powerful and can give us some great ways to answer questions with confidence, it's not always the best choice of strategy to use, and I think this particular problem is a good example of that. So parabola A has x-intercepts at 9, 0, and negative 3, 0. Parabola B has x-intercepts at negative 1, 0, and 5, 0. Which parabola has an axis of symmetry further to the right on the coordinate plane, and what is its equation? So let's go ahead and do this out. Now, I said I don't think Desmos is your best solution for this, okay? So you could go into Desmos and you could plot these points, but you can just as easily plot these points on a regular number line that you're sketching out, probably faster, okay? So the first parabola has x-intercepts at 9, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and negative 3, 0. Here. Oh, there we go. And here, I should probably do that with my mouse than my finger. Okay, so there's where the x-intercepts are. Now, we don't know exactly what this parabola looks like. So it could be something like this. It could be very wide and shallow, like doing something like that. It could be steep and narrows, so it goes way down off the bottom. It could be flipped over this way. Okay, we don't really know. What we do know is that it crosses the x-axis here. Now, this is essentially a vocabulary question. It's asking you, what is the axis of symmetry? So you need to know something about the axis of symmetry in order to answer the question. And what you should know about the axis of symmetry is it goes right through the middle of your parabola. So if you have these two x-intercepts, okay, the axis of symmetry is going to be in between them. So I have one. If you can see my little, I'll change the pointer here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So halfway between them would be 6. So 1, 2, 3, 4, 5, 6. That would put me right here. And there's my axis of symmetry at x is equal to 3. And that was parabola A. And now we'll repeat the process over here for parabola B. And we have x-intercepts at negative 1 and 5. And it's true I did not do that very well, but worst tick marks ever. Okay, and counting the tick marks. So we have 1, 2, 3, 4, 5, 6. I'm not counting the tick marks. I should say that more clearly. I'm counting the spaces as I move between the tick marks, and your axis counts as one. So counting the spaces. So 1, 2, 3, 4, 5, 6. Halfway between would be 3. So 1, 2, 3. So it would be right there. And this is at x is equal to 2. And this is parabola B. So the question is, which parabola has an axis of symmetry further to the right? Well, one of them is at x equals 3. The other one is at x equals 2. So it would be parabola A. And we want to make sure we pick the correct axis of symmetry. So that would be the axis of symmetry for parabola A. And that is probably faster than trying to type those things in Desmos, because it doesn't have to be super accurate. Desmos is great for when we need stuff to be really accurate, like we need to see if two graphs match up, or we need to see the exact points of intersection. But if all we need is a quick sketch, we're probably better off doing that by hand. Okay, so there we go on problem 28. And again, the key content there is that axis of symmetry and how the axis of symmetry is related to those x-intercepts. This one you'll also notice does not have Desmos. Now you could do this on Desmos. You could type in option A, type the whole thing in, option B, type the whole thing in, and then look for the option that matches. And that will work, but it's going to take you time. Okay, remember on your EOC, you have between 2 and 3 minutes for every question. So what you don't want to do is spending like 3 minutes when you could just spend 1 minute on it. Okay, that's like 3 times as much time and it's going to eat away at something else. So if I look at this, I can see that this is absolute value. I can tell you that it is flipped over and that it went up 3. Okay, I'm looking at the vertex there, and vertex is up 3. So to answer this question, it does require that you know what the parent graph will look like. Now, as I look at my answer choices, we can play process of elimination. In fact, there's a great way to do that on this question, because most of you are going to be most confident in that up and down transformation, how you make something go up. Well, to go up 3 is to add 3 outside. And so we could just start with that. Adding 3 outside. Oh, look, there's only 1. We got it. And that took me less than a minute. And that was with making some notes and trying to explain it as I went, so we could do that even faster. Yeah, so the first one, now if you just to analyze the answer choices, all of them have the flip. Okay, so there was nothing that was done in that to confuse you with the flip. The first one though would go left 3, the second one goes right 3, the third one of course goes up 3, and the fourth one goes down 3. And so they put all 4 transformations in there, and you just have to pick the right one. If you use Desmos for that one, you will probably get the correct answer, and you will take 3 times as long as you need to get the correct answer if you just know a couple of the transformations. Okay, next one. So this one is a division problem, and I'm going to work this one out. Now, whether this is better, oh, and I don't know why there's a weird 5B beside answer choice D there. I can't explain that. I don't know how that happened. Somebody copied, pasted it from somewhere and got something else stuck in there. Now, this one is debatable, like maybe what the best way to do it is. So I'm actually going to time myself, at least for a little bit on this. As soon as I click on the Desmos, it's going to, there we go, I'm going to put the stopwatch on, is going to kick me out from where I can see my clock on the top. At least I hope so, because otherwise it doesn't really work. So for the first strategy, I'm actually going to do the polynomial division out. And so I would look at what it is I'm dividing, and that tells me how many columns I need. So if I've got a cubic, we're going to have 3 columns. And then that tells me how many rows I need. So we're going to be dividing by x plus 2. And then the x to the third goes into that top column there. And then we ask ourselves, what do I multiply x by to get x to the third? In other words, what would go here? And we would, of course, say x squared. And then we multiply to get this box right here. So 2 times x squared is 2x squared. And now comes like the tricky part. I have negative 6x squared. If you're looking up here, negative 6x squared. So what plus 2x squared would give me negative 6x squared? Now you got to watch the sign. That is a negative 6x squared. So this would have to be negative 8x squared. x times what gives me negative 8x squared? Well, that is negative 8x. Now, I can now eliminate 2 answer choices because the middle is not correct. Okay, because we know it's going to be negative 8x squared. Negative 8x times 2 is negative 16x. And now I've got to look at the negative 3x. So negative 16x plus what would give me negative 3x? That would be positive 13x. X times what gives me 13x? That is 13. Now that doesn't help me. My 2 remaining answer choices are both up to 13, so it's going to come down to that remainder. 13 times 2 is 26, but I need a 1. So that means this must be negative 25, which is going to give me answer choice B with the negative 25. So that took me 2.5 minutes, give or take, okay, which is within the time frame that I have to work on the EOC. Now, I'm doing this writing on a computer screen and talking out loud. So conceivably, like, you might move a little bit slower than me doing the actual problem out, but you're also not going to have to be doing those other things while you're doing the problem. So it might come out about even. So we're talking about 2.5 minutes there on that solution. Hopefully that looks familiar now that I did it, where you've got to get the polynomial you're dividing on the inside and your answer is going to be the top. Now, suppose you wanted to use Desmos. Okay, so you're like, that was a hot mess, Miss Taylor. I don't want to do it that way. I would like to use Desmos. So here's what it would look like on Desmos, and I lost my clock. Okay, so I'm going to type in the thing that I am dividing. So x to the third minus 6x squared minus 3x plus 1 divided by x plus 2. Okay, and I get that graph, and what I need to do is find which one of these matches the division problem, because if they're equivalent, okay, they're just like written in different ways, they should generate the same graph. So starting with the first one, I have x squared minus 4x plus 5, not that, minus 9 over x plus 2. Okay, and that obviously doesn't work. And now we can go to the next one. I moved down to C. I don't know why I moved down to C. But for C, I have to actually hit the right buttons. We keep the minus 4x. This becomes minus 11. And this is minus 21. And that is obviously not the same. Then I would do the next answer choice. So that's going to be minus 8 plus 13. Whoops. There we go. And then first one is 25. Wait a minute. Why does that not match? It's 25 over x plus 2. Did I do something? Uh-oh. Plus 13. X plus 2. Uh-oh. Why don't those match up? Oh, I typed this in wrong right here, which probably some of you were yelling at your screen. Now they match up. Ooh, okay. So there we go. Yeah, so case in point. Now that took me 2 minutes 21 seconds to do, so about 10 seconds less, but I did make a typo. So a couple of things to keep in mind with that. One, I made a typo. You make a typo in Desmos, not gonna work, okay? And the only reason I even caught that typo when I did was because I already knew what the right answer was. and knew that it was supposed to match up. The other thing to keep in mind with that time difference is that you might get really lucky and the very first one you type in is going to match, but it also might be the last one that you type in. So that one was very, very comparable. Again, something else that'll make a difference there too is how proficient you are at using Desmos. And I know I keep saying this over and over and over again, but you need to be practicing on Desmos. You need to be typing these in. You need to be getting fast and fluent at using the keyboard and the different kinds of keystrokes in order to be able to do things the fastest way. Okay, so that was question 30. All right, so I kicked myself out of the slide. It's gonna surprise exactly nobody. And I'm gonna stop my timer. So this is the sum of two cubes. So we're gonna approach this a couple different ways. And the reason I ended up kicking myself out, I was trying to turn visibility of a graph on and off, and you'll see I'm gonna look at this a bunch of different ways. But this is the sum. Okay, so plus sign means sum, and it is the sum of cubes. And the way I recognize that is because I recognize obviously that p cubed is a cube, and that 64 is 4 cubed and 125 is 5 cubed. So everything in there is cubed. Now on your reference sheet, which I think I have a copy of right here, there is a up here in the upper left, mislabeled as cubic functions. I don't think that's the right label for that, but it is up there. You've got two formulas for factoring the sum and difference of cubes. Now, there is a way to teach this, and back when we did it, I did this with dividing to try to reinforce polynomial division, but there's another way that we do this called like the soap sandwich. And so as I'm looking at it, I'm thinking that's the fastest way for me to do it. So I'm going to start off, and you could start it off this way too if you recognize, I know that's blurry, where you've got the formulas in there, that it factors into a small parenthesis and then a big parenthesis. And usually when we do this, we use something called the soap sandwich, but it turns out all we're going to need for this problem is SOAP. SOAP is an acronym to get the operators, and it stands for same, opposite, always positive. So if the original problem had a plus sign in it, then the answer starts with the same sign. Then the next operator is negative, opposite, so same sign, opposite sign, and then always positive. Now, if I look at my answer choices, I am looking for an answer choice that has plus, minus, plus on that. Somebody's at the door. Hang on. Okay, I'm guessing we're recording. It's really hard to tell. Okay, so with this, let me click there. Okay, so yeah, that was about a 40-minute break in between where I like paused the video there. So if I can remember where I left off with the signs, we're looking for something that goes plus, minus, plus, and that right there is actually enough for me to get the answer. Because there's only one that does plus, minus, plus. And so that would have to be my answer choice. So I can actually, if I know this, or you look it up on your reference sheet for the cubic, it says cubic functions on there, but you can get it from there by matching up the signs. In fact, if you know that it's same, opposite, always positive, you could actually get it even easier, because if you look at, if it goes same, opposite, well, A is wrong, okay? Same, okay? Like those two match, these two match, that would be opposite, opposite. There's actually only one that goes same, opposite. And so you wouldn't actually need to do the rest of the problem. on that. Again, how some people seem to answer the questions really fast. Well, they're not doing the whole problem. They recognize this is the kind of problem and this is what I'm looking for. Now, to fill in those blanks, what you do is you actually take the cube root. Okay, and you ask yourself, what cubed gives me 64? Well, that is 4, and that goes in the first spot. What cubed gives me p to the third? That would be p. And what cubed gives me 125? That would be 5. And there's your 4p plus 5. And then to get the other one, you square those. So you square the 4p, you square the 5, and those become like the ends. So 4p squared would be 16p squared, and then 5 squared is 25. And then to get the middle part, you multiply the 4p and the 5 together. So 4p times 5 would give you 20p. And of course, that matches up with everything that we knew was in D. Now, you may or may not feel confident with that. So you can also do this by graphing and trying to match up the graphs. But I'm not going to do it that whole way. So remember, if you want to do the graphing, you do need to use an x instead of a p or a y or whatever else you've got in there. So we'd have to do 64x squared plus 125. Now, watch what happens when I type in this first answer choice, though. So we'll have 4x plus 5, and then 16x squared plus 20x plus 25. Oh, good grief. Do that again, plus 25. That looks like an okay match, but it's not. And you can tell if you look at it closely. And this is one of those drawbacks. I don't think it's going to happen to you a lot. But if you look at the middle, okay, if you look at the middle there, okay, I'm hoping I'm seeing 2 laser pointers. I don't know why. But if you look at the middle, it seems like it matches up. And then as you move out towards like the positive 10, the negative 10, it looks like you can't really tell that you're seeing the green, but it looks like the line is getting thicker or hazier. And but that, if you're going too quickly, you're going to have a hard time seeing that. The second answer choice on that one, we would, I went to answer choice B. Sorry about that. 4p minus 5, and then this is a minus 20. That is obviously not right. And then answer choice D, so you can see the correct answer choice looks like that. But B and D are both really, really close. So that's a little bit trickier. I didn't take you guys through the first one, so I guess I can do that real quick. The 4x plus 5. Okay, and that's not even that's not even close. Okay, now there is another way that you can do this, and that is if you want to use the P. Okay, so when you get this, I just learned this today in class. So when you get the P, it gives you the option, do you want to add a slider? Now, what that means is that it's going to plug in a number for you. So if you've got 4p to the third plus 125 and p is equal to 1, and it evaluates it. And you can slide this and you can see, okay, what happens when p is equal to 7.4? What happens when p is equal to negative 10? And you can slide that back and forth, okay? It doesn't actually matter where you leave it. So I'm going to leave it at 1.8. Now, when I plug in my first answer choice, 4p plus 5 to the third power, what you can notice is that the two numbers don't match up. Now, if I slide them, you can tell both expressions are changing value, but they're not the same. Now I can try the second one. This actually might be better than doing the graph. I don't know why I have that. It's awesome. P squared, I have like that weird exponent sitting there, plus 20p plus 25. And you can see that the numbers are not the same. Okay, so therefore, and that's a much clearer than the graph was. Now, if I come back over here to kind of where we were, you can see that the numbers are much closer together. So we get over to like, yeah, negative, well, kind of moved it a little bit too much, but they are closer when they're over in the negative area. All right, looking for the next one. So that would be 4p minus 5, and then this would have to be a minus 20. Again, the numbers are not matching. It doesn't matter where your slider is. You're looking for something that matches. And then the last one, we would make that plus, and notice that the numbers match. And they should continue to match. So no matter where I slide my slider, they would match. And so that's another way that you can do that, possibly better than trying to match the graphs in this case, because that answer choice B was really close in terms of the graph, but it was apparent when you were dealing with the slider that no, the numbers did not actually match up. So that's the different ways that you could tackle number 31. And because I messed this slide up, I gotta do this the hard way. Great, so this is a trickier problem, and I debated doing this out the long algebraic way, and I didn't like that either. So my take on number 32 right off is, I think this is one I would skip and come back to. So we've got the function f of x is 5x plus 2, and g of x is 9 minus x squared. And we are asked for f plus g of k minus 3. So yeah, so I kind of debated like what is the best way to do this, and you can't really do it with a slider because you've got these weird mixed variables in there. And so I was looking at like, what can we do with that, to Desmos our way around this one. And I did get it earlier. I don't know if I can remember what I did. So f of x is equal to 5x plus 2. And then g of x is equal to 9 minus x squared. And what you would have to do if you did this out the long way is you would have to add those two functions together, which is not a big deal. So you'd have like negative x squared plus 5x plus 11. But then you would have to take k minus 3 and plug that in everywhere you have an x, which is going to necessitate like squaring the binomial, which is not necessarily a big deal, but it's going to have some steps to it. What you might be able to do instead is remember that f plus g of like blah, blah, blah. Okay, it doesn't matter what you have there. The definition of that is f of blah plus g of blah. Okay, it doesn't matter what the blah is. So it could be just x, or it could be like k minus 3. So what I thought about trying to do was losing my cursor. There it is. Okay. So I thought, well, what about doing f of x plus f of x minus 3 plus g of x minus 3. Okay, now that gives me the green graph there. So what I want to know is which one of these answer choices matches the green graph. So I'm going to go ahead and unvisibilize those first two just because they're cluttering up the workspace a bit. I just had to put them in there to be able to tell Desmos, hey, I want to add these two together. And now like I'm going to be using x's instead of k's. So the first answer choice is negative x squared minus x minus 21. I don't even know where it went, but it's not a match because I'm still seeing the green. Next one is negative x squared minus x minus 13. So I'm going to save myself some time. I'm not going to retype the whole thing. I'm just going to change the 21 to a 13. Nope, that's not it either. Next one is negative x squared plus 11x. So I have to come over here and edit this to plus 11x minus 21. And you might have noticed that we stumbled across the answer there. That does not match up. And answer choice D. And that one matches up. So like now I have my answer choice. I think that is probably the best way for most of you to do that problem. Now, the other strategy would be to add them together to get f plus g, which is going to be negative x squared plus 5x plus 11. And then you've got to plug in k minus 3 in everywhere that you have an x. So, and then this is where a lot of people are going to have an issue. I don't want that, but I'm going to accidentally make it go away. So we have negative, and then this will be k squared minus 6k plus 9 plus 5k minus 15 plus 11. And you're like, most of you have checked out. You're like, I'm not doing that, Miss Taylor. Negative k squared plus 6k minus 9 plus 5k minus 15 plus 11. 6k plus 5k, this should be an k, is 11k. And this would be negative 4 minus 9 is negative 13. And I did that super fast, okay? Because I've done that and I can square a binomial in my head and I don't have to do an area model or anything because I've done this for a really long time. So I don't need to do those steps. For most of you, that's going to take much longer to do. And it's also very error prone. So if you make any kind of mistake with a substitution, squaring the binomial, distributing a negative, you're going to end up just in the tall grass and you're not going to find your way out. So I would recommend Desmos for this problem, but as I said at the very beginning of the problem, I would also recommend like you start this one and you come back to it because we do have those faster problems that we can do much quicker. We're going to see some faster problems coming up really fast. And you don't want to scramble too much on this, but do make your notes that, f plus g, and then you can just put in this case, like x minus 3. Okay, you can just use an x for whatever the variable is, and then test out your answer choices and try to match that graph. I don't think you can use the slider on this one because of the notation on it. So you don't have just the k there. You have to start with that f of x. All right, so this one I have some mixed feelings about, just in terms of how the question is written. You're probably more likely to see a arrow like that than you are to see the word approaches. So like answer choice A, I think you're actually more likely to see this f of x, and then you'd see that arrow and then the 0. And the way you would read that arrow is approaches. Okay, now think about what it means to approach. Approach means to come near or get close to or get closer to. So f of x approaches 0 means f of x is getting closer to 0. Also remember that f of x can always be replaced with a y. Okay, so if you're more comfortable, you could say y approaches 0. So this requires a little bit of interpreting what you're looking at. Okay, there's not anything to do really with this. You just need to interpret what you're looking at. Now, we do want to look at the graph. So we're going to put in f of x equals, and then we did go over this last class, like where can you go to get that cube root? So I got to click behind me and we're going to go, and I can't use the scroll wheel. Learn these lessons. Not when I'm in a PowerPoint. I can't scroll down the menu. So we go down to number theory, which is down at the bottom, and that's going to allow us to put in the cube, and then we have the minus 4. And that tells me what my graph looks like. So it says, which of the following describes the end behavior as x approaches infinity? So what on earth does it mean that x approaches infinity? That means x gets close to infinity. Well, where does that happen? That happens over here on the right. You could also read this as x gets bigger. Okay, if it's approaching infinity, it is getting bigger. So as x gets bigger and bigger and bigger, that would be this way. What is my y doing? So we've got y approaches 0. So you might be thinking that. Now remember, your y is your vertical axis here. And say, well, it looks like y is getting closer and closer and closer to 0. Like, I'll buy that. Y is getting closer and closer to -4. No, like as we're moving to x is infinity, we're definitely not getting closer to -4. Y approaches infinity. Okay, so that would be like it keeps getting bigger and bigger and bigger. Now it does look like my y value is getting bigger and bigger and bigger, so I'm not going to rule that one out. And then y is approaching negative infinity. That would mean the y value is getting smaller or going down, which it is not. So it is, I can't find my marker. There it is. So not that. So now we have to differentiate. Is this getting closer and closer to 0, or is it getting closer and closer to infinity? So what I might do for that is I might play around with Desmos for a hot second and see if I can get the y value to be bigger than, like, I don't know, bigger than 0. So I'm going to try f of 10. Okay, f of 10 is negative 1.8. So getting closer to 0. Let's try f of 20. Still negative. Okay, it's still negative, but it's less negative than it was. I'm guessing we need to go much bigger. Let's do f of 100. Aha, there we go. F of 100. That's the lazy man's way of plugging numbers in to see what they're equal to. Notice that it is now bigger than 0. And so that helps us rule out the answer choice A. It's not getting closer and closer to 0 because it just passed the 0. So, if I wanted to try 1,000, okay, now we're all the way up to y equals 6. So it looks like our y value is going to get bigger and bigger and bigger, which means it's got to be approaching infinity, not the 0. And make sure you are making some notes in your packet about end behavior, what it is we're talking about. We're talking about where it points at the ends, and that how to interpret the word approaches, that if you see the arrow, that's what that means. It means getting closer to. All those like little notes. Also note how I did this on Desmos. I graphed it and then I started plugging numbers in. So put the equation up there and then start plugging some numbers in and see what happens. Okay, so that brings us to our next problem. Now, this one, for me, is probably easier to do out by hand. I think I can do this faster on my own than I can do it on Desmos. So because that is the name of the game when people don't come in my room for like 40 minutes, it's okay. So we're going to reset this. And I'm actually going to start the timer and I'm going to work this problem out. So in order to solve this, I need to isolate the radical. On a recent test in this class, people did not want to isolate stuff before trying to mess around with it. So when you're solving stuff, equations, a lot of times you do need to isolate. You need to isolate a squaring or square root or an absolute value. Or a logarithm or an exponential. You need to isolate it before you can undo it. So I'm going to start by adding the 11 to both sides. Please undo any adding or subtracting first. I am continuing to see people wanting to divide first, and I don't know where that habit came from. Now I can divide, not subtract, because that is not addition. Okay, now I can undo the radical. So that is a cube root, and I can undo a cube root by cubing. Now I'm out of space, so I'm going to move up here. When you cube a cube root, you get what is inside. So I have 3x plus 1, 4 to the third power is 64. Then I will subtract 1 from both sides and divide by 3, and x is equal to 21. And I'm pretty happy with that. It took me 1 minute, 30 seconds to do that. 1 minute, 30 seconds. Okay, now, if you're comfortable with that, you're like, yep, I remember that. That was my best test all year. That was awesome. I'm going to solve it that way, copy down the work, get that little refresher. You are good to go on this. If you are not comfortable, then you need to go breaking up house upstairs. Then you're going to kick over into Desmos, okay? And in order to do this on Desmos, you need to graph the left, graph the right, and then you need to find the point where they intersect, okay? So we're going to start with 2. Then I need my cube root, so I've got to come in here. And this will be the cube root of 3x plus 1. Got to kick out of the cube root. Oh, and that should have been y equals. If you don't put the y equals in the beginning, you can put the y equals at the end. That's fine, because it's just whichever way. And then I have y equals -3. So you graph the left, and then you graph the right. And then you want to see where they intersect. And they intersect somewhere, I don't know where. I zoom out. I zoom out some more. And there is my point. And then we are looking for the x coordinate of that point. And so that would be the 21. And I already have the 21 circled over there. So that one took me about 1 minute and 15 seconds. So a little bit faster. I think it's a little bit faster, though, because I didn't have to do as much explaining. So I think if it were just me and I wasn't trying to explain the steps of my algebra, I think it would have been faster. Comparable, though. Both are valid ways of finding the x equals 21. Okay? And that brings us to our last problem, which you will note does not have any Desmos. This is vocabulary and being able to recognize the family of functions. This is an example of why you do not spend too long on problems that are clearly going to take you more than that 2 to 3 minute window to answer. So because the very last problem on the mock EOC is really simple to answer. That is not exponential. Okay, so just as a quick refresher, exponentials look something like that. Okay, we haven't really looked at logarithmics, but we have looked at square roots. So that hopefully you recognize as a square root. Logarithms do something like that because they're inverses of exponentials, and cube roots, we just saw one of those. They do something like that. And then that, of course, is the square root. So you don't want to leave a question like that out there on the table. You don't want to have to rush through it because you didn't leave yourself enough time to read it. And so gauge those questions. One of the points of the mock EOC is to start to gauge how long it's going to take you to do something. Some of the problems are going to take you more than that 2 to 3 minute window that you have per problem. Like they just are. Some of the ones where you might have to type everything in and do a regression. Some of them are going to be this fast. Okay, you're going to look at it, look at the graph, read the descriptors or whatever. Oh, that is 3 to the left. That is a +3 on the inside of the absolute value, and it's going to be that fast. And then you use that time on some of the ones that take you longer, but you want to budget the longer ones for the end. So that is it for our mock EOC. That was all 35 questions, and we've covered a lot of ground in there. So what we'll do with the remaining study time that we have is we're going to go back and hit those questions again that you feel needed a little bit more explanation. And we can also talk more about vertical asymptotes in our rational functions.